Hello, I've had a question from Unit 4, Lesson 6, Part 2. So, number 38 is a trough is being made by bending a long rectangular piece of tin 3 units wide, and the cross section of the trough is an isosceles trapezoid. So, looking at it from the face, it's going to look like that, and we are bending it so that these two sides are the same, and also it's bent such that those angles are 120 degrees. Now the trapezoid, in order to optimize this shape, even if it's going to handle a volume, we're not too worried about the overall length of the trough because that doesn't change. It's the cross section that's important. So we're going to optimize area. So area for a trapezoid is 1/2 the height A plus B. So if we label the sides accordingly, A, B, and I'm going to label these sides X because we don't know them. We need to find some constraint equations to help us out. So we're looking for H, A, and B. So let's start with length B. So we know that, first of all, that the total length here, if we add up 2x plus b, we know that we are dealing with a piece of tin. It's a total of 3 units wide. Alright, so that means that b is going to be 3 minus 2x. So there is my first constraint equation. So now I'm going to go on to height, and what I'm going to do for height here is I'm going to use a bit of trigonometry, because if that is 90 degrees, we know that the remaining angle is 30 degrees, and from the first part of this course, we know that if we want to find the height is simply the hypotenuse, or the x value, cos 30 degrees. So there is my height. I know height now to go in there. Cos 30 is just a number. Finally, I need to know my a value. So my a value is going to equal my base, the b value. Alright, so here's b. So a is going to include that, but then it's going to include the two wings, or the x components. So I'm going to find my x components. So plus, oops, wrong pen, plus 2x sine 30. Alright, so now sine 30 is just 1/2 if you plug that into the calculator. So b plus 2x times 1/2. So that means my a value is b plus x. And I've already defined what my b value is. So that means that a is going to equal 3 minus 2x plus x. So I replaced b with what I said it was. So a equals 3 minus x. So there is my third and final constraint equation here. So now I'm able to plug these values in. So for my area, it's equal to 1/2 my height, which I said is x cos 30. The only reason I'm dragging cos 30 along is because it doesn't work out very nice. My a value was 3 minus x, plus my b value, also in a box, was 3 minus 2x. So that means for my area, it will be 1/2 bracket x cos 30. Inside there, we can see that 3's cancel, and we end up with, oh, sorry, the 3's don't cancel, that's my mistake. The 3's actually go together to create 6 minus 3x. Alright, so distributing, so I'm going to keep the cos 30 over 2 out front because it's just a number. Distribute the x in, it'd be 6x minus 3x squared. Now I can take the derivative of the area with respect to x to optimize. So the cos 30 out front, and inside I'm going to have 6 minus 6x. To optimize, we let the derivative of a with respect to x equals 0. So 0 equals cos 30 over 20, 6 minus 6x. So I can divide both sides by cos 30 over, oops, it became For some reason it became 20. It should have been just 2 all the way down. I apologize. But regardless, it cancels out. So that means that 0 equals 6 minus 6x, or therefore x will have to equal 1. So we know the wing length then for this particular question. The wing length must be a value of 1. If you have any questions with that, let me know and I'll try to clear them up.